start anyway. Due to a technical problem, dia tulis. Arif masuk balik. Alamak, Arif Anwar terkeluar. Pelik saya. Okay, it's recorded now. Nanti minta Arif masuk balik kawan tolong WhatsApp Arif, Arif Anwar tolong masuk balik. Dia kata due to a technical problem, some of the people will be removed. Hari ni, pagi ni orang kata YouTube lah ada problem. Macam-macam. Itu benda yang kalau face to face tak akan ada problem. Okay. Okay, we recap some of the concept. Yeah. Alright. Last week we already learned some of the direct method and we already proven some of the theorems. Okay. And just to recap you guys with some of the examples, we have one more question. Okay, just to refresh you all semua. Soalan ni lah, sekejap je. We already covered direct method. Alright. Direct method is based on the concept of the modus ponens of argument, the method of affirming, which we assume that if P implies Q, we assume P is true, then the conclusion is true. Okay? Ini fundamental dia lah. So, in this question, example 2, it states that if X and Y are odd, forgive my grammar, X plus Y is even. I think we already did this example, but that's fine, we just recall it. Alright, we have implication, we have the condition, ni implication dia. If X and Y is odd, then the conclusion X plus Y is even. So, let's assume that X plus Y is indeed odd. So, X equals to 2K plus 1 and K can be any integer. And some of you guys says that you confuse K1, K2, tak apa. You can use alphabet, other alphabet, let's say 2L plus 1. L ni L saya, integer. Then, let's test what is the summation of X plus Y. Dia jadilah 2K plus 1 plus 2L plus 1. Open the bracket, it becomes 2K plus 2L plus 2. And you don't finish at this point yet because 2K plus 2L plus 2 is not guaranteed to be an even number. Even number must be in the factor of 2. It's a multiple of 2, sorry. So you can summarize it becomes something like this. And as K is an integer, L is an integer, and also 1 is an integer, then it can be simplified as M. And this M is represented by K plus L plus 1, and this M is another integer. So X plus Y is even. So I just proven conclusion. Don't forget to put a conclusion here. It's proven that if X and Y is odd, the summation is even. Okay. This is the method of a direct one, and it's quite easy to understand. It's follow the direct thinking. Kita assume the condition is correct. We try to test the theory of the condition, and then at the end you try by using your creativity to show that at the end it satisfy the conclusion. Okay, ni dah. A little bit introduction on indirect method, which is also known as a contrapositive method. Okay. Actually, this method is known as indirect because when we want to compare first with the modus ponens, okay, this is the original argument. P implies Q. You show P and you show Q. However, indirect method is almost like a modus tollens. Modus tollens is a method of denying daripada logic. It uses this form of argument because P implies Q is similar with the contrapositive method. You can prove that it is a logically equivalent. This is the original implication. P implies Q. You need to convert first into this part. Okay, there's a reason for the conversion. Later I will explain. Okay, this is argument for the direct. Ini indirect number 2. Oh, sorry. Okay. So for the indirect form, we assume we change first into not Q implies not P. You show not Q as a conclusion not P. Okay. However, this argument on the right will prove the left is correct because it is logically equivalent. Okay, let's go to the example for you to see why we need sometimes to use indirect method. Let's look at the first example here. Okay. Okay, focus please. Suppose this question, you need to prove if x squared is odd, then x is odd. Okay, let me show if we use direct method. Kalau guna direct method, macam mana dia punya cara proving dia? Dan apa akan jadi? We let x squared is odd, so x squared is 2k plus 1. Betul? Okay, so logically speaking, I just want to find what is x because it claims here if x squared is odd, then x is odd. Jadi saya buatlah x equals to plus minus square root of 2k plus 1. And yes, k is still integer. Tak ada masalah. However, please observe this carefully. Ni, mana? What is this? Plus minus square root 2k plus 1. Is this an odd form?
Oh.
Kita tak tahu. Dia boleh odd. Sebenarnya dia boleh odd. Tapi bentuk odd number ialah 2k plus 1. 2K. This is a square root of 2k plus 1. So what I want to say here is that my point exactly is that the plus minus square root of 2k plus 1 is not necessary odd. Dia ada nilai k kalau kamu masuk ke dalam dia akan jadi odd, tetapi tidak semua. Contoh, kalau if k is katakan 1, dia jadi Allah bu. Dia jadi square root 3. This is definitely not odd. So this proof is, orang kata, this proof is a little bit strange. It's not conclusively say that this x definitely will be odd. Okay, so this is the condition where the direct method fail to convince us that this is definitely is true. Okay, so that's why some of the statement we cannot use direct method. We need to use an alternative one. Okay, so we go to the alternative, which is the indirect method. Indirect method dia macam ni. Original statement, if x squared is odd, then X is odd. And you know this is P and you know implies Q. You all dah terror sekarang, dah jawab kuis satu. Cuba tukar kepada kontrapositif. What will be your statement here?
If X is even.
If X is even. Okay, correct? Then
X squared is even.
thank you. Alright. Some of you guys, dia boleh pada awalnya kalau kita ambil pendekatan yang lebih mudah, saya percaya ada setengah student directly dia cakap if X is not odd, betul sebab saya dah ajar not kan, not odd, then X squared is not even, odd, sorry. However, in the integer world, if it is not even, if it's not odd, then it should be even and vice versa. So that's why your friend just now just answered to me, dia tak cakap macam ni, if X is not odd. Dia cakap direct, if X is even. Because if its number is not odd, then it is even. So exactly is that instead of you try to prove the first one here, you change it into the contrapositive form, you actually need to prove the bottom one. Bunyi dah lain. Kita buktikan benda lain sebenarnya. We don't prove that X squared is odd, then X is odd. We try to prove if X is even, then X squared is even. Okay, so let's try to prove this, the bottom one. Prove if X is even, X squared is even. So this one might be easier for you. Let X is 2K, X squared 2K squared. Implies it will be 4K squared. Jadilah 2K squared jadi 2L. So I just proved to you that if X even, then definitely X squared will be even. Okay, because if X is even, X squared is even is proven to be true. Actually, at the same time, you also prove that if X squared is odd, then X is odd because it is logically equivalent. So there are two conclusions that you can see here. First of all, if we want to prove that f X squared is odd, then X is odd, we cannot use direct method because it's not convincing. Then I use indirect method. By using indirect method or contrapositive method, I change it into a contrapositive form. So instead, I try to prove the first sentence. I try to prove if X is even, then X squared is even. And this proof is solid here, solid, jelas. And I just managed to prove if X is even, then X squared is even, which is logically equivalent with the initial thing that we want to prove. So ada soalan? Saya tunjukkan keseluruhan.
Sir.
Boleh?
Kiranya kalau indirect proof dia kena ada dua conclusion lah.
Yes, because the actual proof that you want to show if X squared is odd, itu yang kita nak tunjukkan sebenarnya, bukannya yang even tu. Okay? So in order for you to prove the first X squared is odd then X is odd tu, kita tukar, betul? Lepas tukar, kita dapat conclusion yang dah tukar tu, dan kita buktikan it is logically equivalent with the first thing that you want to prove. Yes, Mohsen dia ada dua conclusion.
Thank you, sir.
Yep. Kalau kamu tak tunjuk conclusion yang di awal tu, yang if X squared is odd tu, itu soalan yang sebenarnya yang you kena tunjuk juga. Okay, soalan lain? Ya, hari ni berapa orang ni? Ada soalan, okay. I'm just checking. Lepas ni boleh masuk Google Classroom, jangan lupa attendance cakap yes je, senang je. Hari ni ada beberapa orang tak datang. Saya tengok nama jap. Mana Mamat ni? Tak ada, dia tak datang. Sedih. Alright. Tak apa. Kita teruskan. Tajuk tak datang kot. Ada seorang lagi tak datang kot. Kelas saya 64, campur saya dalam ni patut 65. Tak apa, dia tak datang tak apa. Janji dia tengok video saya, harap dia faham lah. Okay. Kita pergi ke soalan seterusnya. Another one that involves indirect method. Okay, this one is also easy. Ada jawapan kat bawah, tetapi I always like to show to you, to my students, why direct method fails. Saya suka tunjuk. Sebab student kata, sir, kalau kita dapat soalan, kita nak guna yang mana satu? That's the most popular question. And I always say to them back, direct method is the easiest. Always attempt direct method first. If direct method is not convincing, then you go to the alternative method. But direct method is the best. But direct method is not always successful, like this one. Okay, if f5n plus 2 is odd, alamak, then n is odd. It also put here n is a integer. Okay, dia cakap macam tu. Okay, suppose I want to use direct. Error lah, salah. Okay, so direct method implies that I assume that 5n plus 2 is 2k plus 1. Then I want to show what is n actually. So n will be 2k minus 1 over 5. So, again, we already get the answer already. N is 2k minus 1 over 5 pula. So this one, n is not necessarily odd. Again, nampak macam odd, tapi sebab dia per 5 kat situ. So this proof is inconclusive actually. Atau is vague lah, is ambiguous. So actually you cannot use this. So let's try to change it into an indirect method. Indirect method, instead of you try to prove that if 5n plus 2 is odd, then n is odd, you try to change it into a contrapositive form, which is if n is not odd, then 5n plus 2 is not odd. And again, because in the integer world, kalau bukan odd, dia adalah even. So actually it also implies I want to prove if n is even, then 5n plus 2 is even. Let's try to prove this. Let n is 2k, and this k of course is an integer. 5n plus 2 equals to 2k plus 2 becomes 10k plus 2. Then we get a multiple of 2 here. Then as k is an integer, 5 times k plus 1 will also be another integer. 5 equals to 5k plus 1. And this L is definitely an integer. So it's proven actually proven that if m even, then definitely 5m plus 2 will be 2l, which is also even. And it is logically equivalent with this. I also proved that if 5n plus 2 is odd, then n is definitely is odd. Senang dia. I show you the whole proof. And that is it. That is about indirect method.
Doktor, sorry
Ya, saya.
tanya. Dia macam soalan dekat test kan? Nanti dia akan tanya proof indirect method, using indirect method ke direct method ke?
Okay. Bagus soalan tu sebenarnya. Actually, sometimes I cannot recall all the question that I made, but sometimes I actually say by using direct, by using indirect, by using contradiction. Sometimes I say that. However, for the obvious one, sometimes I really like to say by using any method, by using any valid proving method. Kadang-kadang saya tanya macam tu. Kadang-kadang saya campur. So nak jawab soalan awak, kadang-kadang saya beritahu, kadang-kadang saya tidak beritahu. Kenapa kadang-kadang saya tak beritahu? Okay, because proving, there are many strategies of proving. Kadang-kadang obvious sangat. Contoh, proof that these two statement is logically equivalent. Sebenarnya cara pembuktian kamu adalah menggunakan direct method, tetapi saya tak perlu cakap. Nak tunjukkan dia logically equivalent, you just need to show that by using the biconditional between P and Q, they are tautology. Itu sebenarnya direct method awak, tapi kita tak perlu cakap. Tetapi ada setengah soalan memang yang kalau macam susah sikit nak nampak, saya akan cakap please by using indirect method, solve this. Itu kadang-kadang saya beritahu. Untuk mathematical induction, definitely saya beritahu. Saya tak pernah tak beritahu. For the question of mathematical induction, memang saya beritahu. By using mathematical induction. So, you cannot use other method except the mathematical induction. Actually, for the question of mathematical induction, soalan yang macam mathematical induction, dia ada cara lain. Tetapi saya nak paksa you all untuk master the technique of mathematical induction. Thank you for the good question. Kejap saya nak pergi tempat lain jap. Asyik-asyik dekat bang ni je. Saya nak balik ke bilik jap. Okay. Alright. We take a break for 2 minutes only. 2 minutes. Break yang pendek. Semalam hari shopping ramai shopping Korang beli apa yang mahal? Atau yang murah? Tak kisahlah. Duk kata semua murah. Tak semestinya kita beli Oh, tarif paling bantu tu. Satu. Okey, saya akan pasang satu lagu. Baru-baru ni saya dengar balik. Okay, siapa dapat teka lagu apa?
Polaroid.
Woi, laju. Lepas ni saya nak buat lagi game tu. Saya tak suka sangat lagu-lagu latest baru-baru ni. Akram nak nyanyi lain kali lah. Kita kalau ada orientation day nanti, kita ada PA day, nak nyanyi-nyanyi lah. Sebab tahun lepas saya nyanyi dengan senior kamu. Jawapannya tak shopping. Saya dah kekurangan duit bulan ni, honestly. Ya. Yeah. Tak lari bajet. Saya tak beli Lazada semalam. Saya beli Big Bad Wolf untuk anak saya buku. Big Bad Wolf pun ada kat 11-11. Shopee PS5 memang tak dapat lah awak, Arif. Oh ya, PS5 boleh pre-order Jom kita tengok. Lepas ni lepas kelas. Kita Abang kata apa? We try to imagine if we have the money. Habis dah? Kau biar betul. Pre-order buka pukul berapa ni? Lajunya habis. Okay, tak apa. Kalau dah habis, kita nanti pinjam pakai dekat kawan yang beli. Sebab kawan-kawan saya, lecturer data analitik, ada seorang nak beli. Tak tahulah dia betul-betul nak beli atau berangan nak beli. Saya memang tak ada impian nak beli PS5. Sebab tahu tak ada kekurangan masa nak main. Pakai filter PS5, oh ya. Yeah. Saya kena tipu hari tu, wajar. Yes, Dr. K mesti dia sebut tu. Nak PS5. Dia ada PS4 dah. Saya tahu lah PS5 is better from PS4. Maybe, perhaps, sebab PS4 pun saya tak ada. Mungkin saya boleh beli PS4 dia. Okay, enough of the break. Lepas ni kita break lagi panjang Okay, we need these breaks because after this, okay, it's more confusing the contradiction method. Contradiction method ni dia pelik lagi. Dan selalunya dalam event kelas face to face pun contradiction method saya tak dapat nak yakinkan beberapa student untuk faham contradiction method. Direct method senang faham. Indirect method is just a contrapositive. But contradiction method is special. Kena jadi tak, pemikiran kamu. Okay, thank you for watching my video Dia pemikiran dia macam budak degil. Saya nak cakap budak degil. Stubborn, yes. Dia degil. Macam kita try tengok. Kenapa contradiction method ni dia lain? I teach this kind of subject since I went into a UMP, and I try a various way to make my student understand the contradiction method. Okay, we will not use this example Kita jumpa example yang mudah sikit macam ni. Yang ni sebab korang tak belajar lagi modular tau. Modular, jadi saya tak boleh tunjuk lagi contoh ni. Boleh lain kali bila kamu dah belajar pasal modul lah, arithmetic. Okay. This is almost a similar question like this one, the previous one, right? So it's better for you to relate with it. If 5n plus 2 is odd, then n is odd. As the name implies, contradiction method. It's like your friend just said, it's like a stubborn student who refused to accept the truth. He refused, for example, for this kind of statement, he refused to say that if 5n plus 2 is odd, then n is odd. Dia cakap tak. He believes that if 5n plus 2 is odd, then n is even. Ataupun, dia cakap sebenarnya if 5n plus 2 is even, then n is odd. Likewise, dia try to negate any of the P or Q there. Dia try to negate one of it. Sekejap, ada korang buat chat ke? Tak ada kan? Okay, jangan chat saya tak tengok chat. Alamak. Okay. Alright, so by using that thinking, he tried to prove, kita ambil tadi tu, kita tukar sebenarnya. Tadi tu kita guna indirect method. Indirect method, jangan pening sabar dulu. Kalau kita guna indirect, kita tak boleh guna direct kat sini. Dia kena if n is even, then 5n plus 2 is even. Ini yang kita baru buat tadi. Tetapi kalau guna contradiction method, where they try to negate even the indirect one, instead I try to prove if n is even, then 5n plus 2 is even. I try to prove if n is even, then I say that 5n plus 2 is odd. Saya degil ni, saya degil. Saya tak nak percaya dia even. Saya nak kata dia odd juga. Okay, so by using these premises, okay, I try to prove if n is even, so I let my n is even. And I try to prove that is 5n plus 2 is odd. Okay? I believe that 5n plus 2 is odd. However, after this, we try to do the workings. Becomes 10k plus 2, 5k plus 1, becomes 2l, L is equal to 5k plus 1, and L is integer. Okay, contradict the fact that 5n plus 2 is odd. Thus, 5n plus 2 must be even. Okay, for this case, okay, the proof is complete. For this kind of thinking, he tried to prove otherwise, but in fact, he cannot prove that the otherwise is true. Therefore, the initial assumption is already true. So, the assumption dia contradict kat sini. Mana contradict dia? Sini dengan sini. So, the contradiction assumption is wrong. Therefore, the initial one is correct. So, strategi ini bahaya. Dan strategi ini sebenarnya tidak sesuai untuk kebanyakan soalan. Some of the question sometimes require contradiction method, but you will not always find it in the subject. Dia untuk contoh lain kamu jumpa. Izinkan saya bagi ruang kepada saya untuk tunjukkan contoh contradiction method di mana contradiction method sesuai. Tapi soalan ni tidak ada dalam slide, okay? So boleh abaikan slide dulu. Saya buka besar sikit. Okay, jangan risau because this question I will not ask seriously. This is a question that a mathematical science student should understand. Mana buku tu? Alamak. Okay. Proof, ni untuk pengetahuan tambahan saja. So, don't worry so much. Prove the square root of 2 is irrational. Okay, ambil ni santai je, jangan pening sangat. Okay. What is rational number? When you want to start the proof, you will have a definition first. Irrational adalah opposite kepada rational. Rational number is n that can be made as a p over q. It's in the form of a ratio. So irrational number, as you get it, the opposite is the number that cannot be put in the form of a ratio. For example, pi. Pi is actually irrational because it is 3.141 blah blah blah, saya tak hafal. It cannot be actually put in the form of 22/7. Sebab tu, dalam soalan, sebenarnya pi is not equal to 22/7. They assume or they let pi equals to 22/7. But actually pi is not a rational number, it's irrational because you cannot put it in the form of even a fraction. So square root of 2, let square root of 2 be rational. Okay, ini kaedah contradiction. Contradiction, ni saya nak tunjuk contoh contradiction ni yang tidak ada dalam pengajaran subjek kamu. Contradiction, I believe no, square root of 2 is rational. So square root of 2 equals to p over q. Saya percaya benda tu. Saya percaya square root of 2 is rational. Therefore, q square root of 2 equals to p. By kuasa 2 dua-dua belah, it becomes 2q squared equals to p squared. P squared equals to 2q squared. So, the thing that implies here is that as p squared is even, p is even. You can prove it by lemma, corollary ya. Ni proof yang saya tak mau tunjuk. Proof ni kita boleh proof sebenarnya. Ni boleh kamu proof dah sebenarnya. Tetapi saya tak nak proof di sini. By using indirect of course. Tetapi saya tahu P is even. Itu conclusion yang saya dapat kat sini. Okay, as P is even, therefore P is rational. Kalau Q pula apa? Sekejap, ada satu problem kat sini. Alright. Kalau P is multiple of 2, kita boleh jadikan P equals to 2M. Ambil urut lain lah. Boleh 2M, okay. Oh panjang mesti komponing dah. Alright, so square root of 2 equals to 2M over Q. Q square root 2 equals to 2M. 2Q squared equals to 4M squared. 2Q squared equals to 2M squared. So Q is actually even as well. Alah panjang lah. Saya nak tunjuk kontradik yang ni. Saya lupa the next part lah awak. Nanti saya sambung. Saya terlupa yang ni. Yang ni P equals to 2M. P equals to Q, sorry. Nanti saya kena buktikan Q equals to 2P juga kat sini. So saya henti dululah. Sorry semua bagi korang pening. Baru nak bagi korang idea baru, nak menunjukkan contradiction sesuai. Sebab tu yang ni kami tak pernah tanya. This proof actually I already learn during my degree years. Saya lupa the next part. The next idea saya lupa. Okay. So safely to say saya tak akan tanya contradiction method kepada korang sebab tak ada soalan yang sesuai untuk guna contradiction. Okay, boleh tak kita jawab satu soalan jap yang lebih senang lah, yang menggunakan direct or indirect method. Okay. Ni saya nak habiskan juga nanti. Nanti saya post dalam WhatsApp group. Lepas saya tenang sikit. Okay. Saya pernah tanya soalan yang ini. So saya nak kamu jawab. Soalan dalam final exam. Okay. Saya nak kamu jawab dalam masa 5 minit. Try If X plus Y is even, okay, you need to prove if X plus Y is even. Sekejap saya fikir. No. Prove if X plus Y is odd, then X times Y is even. Okay, saya double check Okay, correct. Soalan ni susah sikit. Tengok, tapi boleh dijawab Prove that if X plus Y is odd, then X times Y is even. Okay, soalan ni menarik. Ada, kalau budak boleh jawab, saya belanja makan kot bila kita berjumpa lah. Okay, this is actually a serious question. Can you prove this? Sambil saya nak habiskan soalan yang contradiction tadi tu. Okay, by the way, are you guys with me? Still with me?
Yes.
Okay, tolong jawab soalan tu. Soalan tu valid. Saya boleh tanya dalam final. Tapi kalau saya dah tanya sekarang tu, saya tak akan tanya dalam final. Tetapi ini soalan level final. Level final for you guys. Sometimes, actually, although this is not a proof, it's good for you guys to visualize the problem, right? Kalau X tambah Y is odd. Okay, maksudnya contoh, X sama dengan 1, Y sama dengan 2. X plus Y equals to 3. Betul. XY is 1 times 2. Is equals 2, is even, betul. However, this is not actually only true for the case of 1 and 2. It's applicable for any number. Soalan ni susah, saya tak pernah tanya. Kenapa saya tak pernah tanya? If anyone can answer, please talk to me. Then I want to see their answer. Saya cuba jawab sekejap, tapi saya rasa dah jawab. Okay, ambil masa nak jawab ya. Saya tengah guna dua-dua kaedah sekarang. Oh, saya dah dapat. Alright. Cuba lagi. Nanti saya tunjuk jawapan dia. Nanti kita rehat panjang. Perah kepala tu. Fikir. But ironically, please do not think so complicated. Kadang-kadang fikir lagi complicated lagi you all pening. Ni mudah je. If x plus y is odd, what is x and what is y? You boleh assume kepada sesuatu. Ada orang jawab ke? Tak ada. Oh, WhatsApp saya punya. Assalamualaikum sir, saya cuba je, tak tahu legit ke tak. Oh, jawab ke sini kamu. Siapa ni? Oh, ni macam kenal muka ni. Sekejap. Malulah. Okey, ada kawan kamu yang pemalu. Kat sini dia jawab dah rupanya. Sekejap. Ni last day siapa nak buat, alamak. Foto. Ni siapa ni? Alah, bagilah nama. Jawablah kat dalam ni. Saya apa ni? Prove by exhaustive case. Yeah, ni betul ni. Siapa ni? 012346 ni. I like. Tapi letak conclusion Maka penuh. 012346. gambar kucing dekat WhatsApp dia. Oh, Aida Akram. Okay, Akram dia. Oh, okay. Okay, Akram jawapan Akram betul. Tapi dia tak cantik macam yang profil kucing ni. Nah kucing. Nampak ke? Ni kucing. Alright. We can discuss. Akram betul, cuma jawapan yang tak. Saya nak belanja yang kucing ni lagi. Yang kucing ni jawapan ni lagi cantik. Thank you for trying you guys. Okay. Kucing tu Leong. Oh, so Leong. Nice. Saya tunjuk lagi sekali takut korang tak nampak kucing tu. This kucing. Alright, let's discuss their answer. Saya tak sempat lagi buat soalan contradiction tu. Okay. I'm glad that some of you guys already managed to answer it. Alamak, terpadam. Okay. Although some of you guys get the idea, but this answer I like the best. Okay, I try to rewrite back what Leong wrote. Saya tak tengok lah, tapi idea dia, the gist is almost similar. Okay, if X plus Y is odd, he separated it into two cases. X dia even plus odd equals to odd. This is the first case. And the second case is that odd plus odd equals to odd. Okay? Silap. Odd plus odd equals to even. Odd plus even equals to odd. Okay. So, contoh dia. Okay, kalau even tambah odd, contoh ni bukan jawapan. Contoh, if even 2 tambah 1 sama dengan 3. Yang kes kanan pula, kalau 5 tambah even, ambillah 10 sama dengan 15. This is the case. There are two cases. Whether X is even and whether X is odd. If X is even, then Y must be odd, and if X is odd, then Y must be even. So we can, for the first case, X equals to 2K and Y equals to 2L plus 1. So we multiply it, X times Y becomes 2K times 2L plus 1 becomes 4KL plus 2K. Seems familiar, right? Becomes 2KL plus sorry. Sekejap. Lepas. Okay, becomes 2M. This M equals to 2KL plus K. This M is definitely also an integer. Saya lupa define kat sini. K is an integer, L is an integer. Alright. So for the first case where X is even, then Y must be odd. Therefore, the multiplication will be even. For the second case as well, follows the same logic. Different is just the first one is odd and the second one is even. X, Y So we managed to prove by these two cases, if x plus y is odd, then definitely the multiplication of x and y is, oops, even. So much Leong, Akram dan kawan-kawan yang lain kerana menjawab.
Sir, kenapa terbalik?
Apa? Apa?
So yang jawapan saya tu sebab dia tak ada apa ni, tak apa ni, apa, saya buat satu kes je, lagi satu kes saya tak buat, macam tu.
Betul. Dia kurang markah. Dia bukan kata you tak betul, you betul.
Oh.
Tetapi dia kena consider semua kes. That's why saya kata soalan ni level final. Kenapa kamera saya terbalik?
Itulah.
Soalan ni dia bagus sebab dia kena student fikir ke semua kes. Kamu cuma consider satu kes, bila consider satu kes dia dia kurang lengkap orang kata. Kamu mesti dapat markah awak, jangan risau. Sebab kamu betul. Saya dah tahu dah kenapa terbalik. Sekejap
Thank you, sir.
Kamera saya tercabut.
Okay, reset. Okay. So tak perlu prove yang plus dulu Plus dulu. Yang mana Devina? Kita dah prove dah yang plus. Kita bukan prove per se. We assume that x plus y is already true. Because in the question Devina, it states that if x plus y is odd. Alright? Jadi ada dua case yang mana x plus y is odd. The first case is that when x is even, then y must be odd, then the summation will be odd, right? And the second one, if x is odd, then y must be even. If x is odd and y is even, the summation of x plus y will be odd again. Jadi kita tak payah proof yang tu, kita assume dia betul. Kita kena proof actually, Devina, kita kena proof yang the product x times y is even. Itu yang kita kena tunjukkan. Bukan yang atas tu. Menggunakan assumption x plus y is odd, we prove that the xy is odd. I hope that answers the question. Kalau tak faham, tanya balik. Takut explanation saya kurang jelas kat sini. Does she mean that we need to prove that sum of odd? The sum of an odd and even is odd. Okay, good question. You can do that but it will be long. Boleh kalau you letak, tetapi macam mana saya nak cakap? Ya, saya rasa ada student yang akan cuba buktikan the sum of an odd and even is odd. However, it becomes macam mana? Perlu ke tak? Kalau saya nak buat soalan tu, kalau saya tak perlu benda tu. If I make the question, I don't really ask you to show the summation because it will be quite short. But if I want to ask, then I will include more marks on that. Maksudnya Devina, okay, I dah faham dah soalan you. Thank you Leong, because clarifying it. You don't need to prove that actually. It's enough, sufficient if you show that if x is odd, then y is even, the summation is odd. It's already understood. But if you want to show it, it is no harm for you to do that. But I need to increase the mark of the question. Kalau saya buat. You tunjuk, dia bergantung kepada markah yang akan saya allocate. Tetapi untuk soalan tu, bila saya buat tadi tu, I really don't think about to show the statement x plus y is odd. Because we already believe that x plus y is odd. That is not our intention to prove that. Harap menjawab. Intan tengah kelas, Intan?
Tak, sorry, tertekan.
Okey. Okey, ada seorang lagi tanya. No, ada seorang bagi jawapan kepada saya, baru kita segera tadi. Jawapan yang kamu bagi kepada saya tu totally salah. Sebab kalau kita assume x equals to 2k, y is also 2l, the summation of x plus y, kalau both of them is even, x plus y it will not be even. So yang baru bagi jawapan kepada saya tadi melalui WhatsApp, salah
Saya.
Ya saya, ada soalan?
Kalau untuk yang kan if x plus y is odd kan, tapi kita assume x is 2k plus 1, y is 2k, lepas tu kita selesaikan dapat odd. Lepas tu boleh proof terus yang apa x plus y is odd ke? Boleh proof terus macam tu.
Ulang balik pelan-pelan Musin.
Kalau macam apa, kita let x is 2k plus 1,
Okay.
lepas tu kita let y is 2k, 2m which is even.
Okay.
Lepas tu kita selesaikan yang if x plus y is odd.
Alright. Soalan ni macam Devina cakap tadi. Kita tengok balik soalan tu. Apa Leon tulis ni? Okay. Let me try to explain back so that Devina dah faham, saya harap faham, tapi saya akan ulang balik supaya Musin pun faham sekali. Okay, this is the original question. Alright, proof if x plus y is odd, then xy is even. We already have this P implies Q. Your P is that if x plus y is odd. Okay, ini dia punya condition. The conclusion that x times y is even. So, what happens here is that we try, by using this assumption, we try to prove this. We are not actually, for this statement or theorem, we try to prove this. Okay, so when Devina asks if we need to prove x plus y is odd, you are not necessarily to do so. You don't need to actually prove this, because this question actually needs you to prove this one. So kalau you prove yang merah pun, there is no requirement for you to do that. You don't need to do that. Kalau kamu buat pun dia tak ada masalah. If you recall the some of the terminologies that we look at, situasi ini dikenali sebagai ini. Saya tunjuk balik Okay, theorem, proposition. Okay, for this case, x plus y is odd yang kat depan ni P ialah proposition. Dia less important theorem. Dia a less important theorem yang digunakan untuk memproofkan yang biru color yang kat kanan ni, theorem yang asal. So, to have a final say, saya guna term parliament ruling. We don't actually need to prove the red color P here. We assume that P is already true. By using P, you try to prove that x times y is even. The blue color part, the conclusion, the implication part that we actually need to prove. Ini yang ada markah. Okay, I hope that answers the, because more respondent. Sun Kenyuan, more respondent, okay, tak tahu tiba-tiba more respondent. This one. Alright, ada soalan lain? Soalan ni best. Tetapi ramai student akan hilang markah kalau di consider hanya satu kes. Hilang markah sikit lah. Maybe at most is 2 marks lah.
Banyak yang relatif. Alah, kamera ni tersentuh lagi. Okay, it's 11:30. We take a break
Minutes before I will start with the introduction to mathematical induction. Yang tu kita masuk sikit je. Selasa depan kita habiskan. Take a break for 5 minutes. Saya nak tengok answer tadi boleh? Saya buka semua, harap boleh nampak ya. Sebab ni jawapan termasuk dengan soalan tadi. Okey. Kalau yang dah biasa dengan penyampaian saya, yang merah tu penekanan yang jangan buat. The red colour is the thing that we need not to do. Atau salah. Jawapan sebenar adalah banyak dalam bentuk colour hitam. Dan kalau saya bosan guna colour hitam, saya guna colour biru. Itu je. Atau hijau. Hijau tu tak ada markah juga ya. Saya kembali. Oh lah, habis air. Okay, siapa WhatsApp ni? Okay. We have remaining around 25 minutes, so I don't intend to do full complete of mathematical induction. We try to get a little bit idea untuk mathematical induction ya. Sabar. Penat.
Sure.
Ya saya.
Kan kita orang dah tahu markah kan, markah quiz. Boleh ke kita orang tahu yang mana kita orang salah?
Nak tahu yang mana korang salah, saya kena bagi balik lah. Tapi okay, I have a question not to you guys lah. Actually, I want to give back your quiz, but I need to give to you personally one by one, correct? Maksudnya saya dah ada jawapan tu sekejap. Tapi nak bagi seorang-seorang jawapan kamu tu, it will be quite a little bit of hassle to me, I suppose. Can I only give the answer? I tak tahulah. Saya bagi answer yang betul. Itu saja the best that I can do.
Boleh.
Itu boleh lah. Okay, some of you are pondering why you get wrong. Actually, macam mana saya nak cakap? Tapi truth table jawapan solid. Kalau you salah tu memang you salah lah. Kalau bayangkan yang salah ni, saya nak komen ialah careless. Sebelum proceed to the right column, the next column, you must make sure the left column is correct first. Because it will drag on the right. Ada yang tak cukup row. For PQR, ada yang buat 4 row. Yang tu saya tak boleh bagi markah lah. Sebab PQR you kena penuh. Kan saya kata satu kolom tu kena penuh. Itu pun ada yang kesilapan begitulah. So for the quiz saya tak risau sangat. Test ni akan bagi markah besar sikit. So harap dapat belajar daripada kesilapan. Okay? Alright. Masih ada 63 orang lagi. Okay. Okay, kita masuk dengan mathematical induction please. Okay? Okay. Kita tak ada 4.5 mathematical induction je. Saya lupa padam yang ni. Nota ni saya dengan Dr. Syam sama-sama buat. Okay. I will not start with this. I will start with this one first. I think you're already familiar with this so-called formula. Okay. I will open a history lesson a little bit. History, sejarah. Tahun ni 2020. Okay, around 200 years ago, there is a young boy. When he learned mathematics from his mathematics teacher, his teacher asked him to count this. What is the summation from 1 until 100? The teacher asked, and the young boy, the 12-year-old, managed to answer this quite fast. Who knows the answer to this? And I suppose that some of you guys already learned the formula. Okay, so that boy actually discovered this. If you add the first digit and the last, 1 plus 100 plus 2 plus 99 plus 3 plus 98. Okay? Plus until, what will be the last bracket here is 50 plus 51. The number, the summation inside here is 101. 101 plus 101 plus 101. So how many 101s are there? Is 50 times 101 becomes 50, 50. The young boy managed to answer it in minutes. That is the story that has been told. Okay, the boy's name is this person, Carl Friedrich Gauss. In linear algebra, you may you may learn about the Gauss elimination. Ada kot, Gauss elimination, Gauss-Jordan. This Gauss is the mathematician. He is known as the person who is very well versed in the field of number theory. Mr. Carl Friedrich Gauss, mati dah pun. He once says this quote: if mathematics is the queen of science, then number theory is the queen of maths. So he also implies here, okay, to all my students, is that number theory that you will learn in chapter 3. Bukan chapter 3, dia modul sekarang. In the module 3, is very fundamental, is very important to the study of mathematics. Then you will realize why. Okay, so right now you have 1 plus 2 plus 3 until 100 equals to 50, 50. If you try to put it into the formula, it's actually will be 50 plus 1 kejap, sejuk. Sorry, it will be 100 times 100 plus 1 over 2. The summation of 1 until 100 is equivalent to 100 times 100 plus 1 over 2. So actually, this formula, you can not only know the summation of 1 until 100, you can actually know what is 1 plus 2 plus 3 plus 2020. This is the year of 2020. You don't need to add up using your calculator 1 plus 2 plus 3 until plus 4 plus 5. Tak perlu. You already know that it can be found in a matter of minutes. It will be 2020 times 2020 plus 1 over 2. Yang ni you boleh kira kejap je. So you ambil calculator, you kira lah. Ini saya tak boleh kira. Kena calculator juga. Becomes a single integer here. The point right now is that you can know that 1 plus 2 plus 3 plus a certain integer n will be n plus 1 over 2 for every n, which is a positive integer.
If we want to prove for all,
then you need to show that it is true for every particular case. Okay? So not only 1 plus 2, not only 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4 until 2020. No, it until n. And n is infinite. N is a very maybe large integer, maybe small integer. It's an undefined integer. So you can imagine this like a ladder. Tangga yang betul. Yes. If you can sum up the first step here, and you can assume that you can climb a certain k step, you try to prove after k will be a case of k plus 1 is true, then you assume that this will be true for every possible n. The idea of mathematical induction is based on this. You assume that the first case is true, hence the first ladder. You assume that the k is true, the step of k is true, and you need to prove a k plus 1 is true. Therefore, you can assume, you can safely proven that you can reach until the n. Ini analogi baru. So, the basic of mathematical induction. Ni contoh je baru. Minggu depan kita pergi banyak lagi contoh. Okay, there are 4 steps shown here, but basically the last step is just a conclusion. So focus please, there is 3 major steps. The first one will be to prove n naught is true. The case of n naught is true. N naught stands for the first value or the first element in the given formula. The second step, you assume, not prove, assume. We believe that pk is true, and the last one you need to prove pk plus 1 is true. Let me add here the key point by proving pk plus 1 is true by using assumption on the step 2. Because the failure of my students to prove step 3 is that they always neglect step 2. Step 2 is as important as the previous step. Step 1. My students always manage to answer first step. Step 2 dia salin balik je. Dia salin balik, dia tidak guna. Actually, step 2 is very fundamental to solve the step 3. Okay, so I would like to highlight this. Please prove the third step, k plus 1 is true by using assumption from 2. Okay, let me check you guys for a while. Adakah kamu masih bersama saya? Ada. Okay, fokus. Alright, I will show you how to prove the formula that we clear just now is true. I want to prove that 1 plus 2 plus 3 until a certain integer n will be indeed n plus 1 over 2. I want to prove that Mr. Gauss is right. For every integer, for every n, aduh. Alright. So the first step is to prove the first base case is correct. Okay, what is the first element here? Okay, some of you guys say the first element is 1. You look here on this blue part. Actually, the best way to look is at this domain. The first positive integer. Itu cara yang terbaik you nak tengok, bukan tengok dekat kiri. You boleh, tapi nanti untuk soalan lain you boleh silap kalau you baca terus dari sini. Actually, you read the first base case n is from the domain. So, the first element in Z plus or positive integer is n equals to 1. So, I need to prove let n equals to 1. Okay? N equals to 1 for this formula. So you have the left hand side and you have the right hand side. This is an equality, which is this is left hand side and this is right hand side divided by this equality sign. For the left hand side, you can get it directly. Left hand side equals to one, because n equals to 1. Nothing, no modification needed here. But for the right hand side, you need to put into the formula to prove that it can yield the same value. So, for the first case, n not equals to 1, left hand side equals to right hand side for the case of p n not equals to 1. So, as my conclusion, n not equals to 1 is proven to be true. For the first element, n equals to 1, kalau kita masuk dalam formula right hand side, dia betul, sama. This formula is true for the first element. Okay, this should not be a problem right now. Number 2, you need to assume that p n equals to k is true. We believe that 1 plus 2 plus 3 until a certain value n equals to k, not n, is k. Because we assign n into a sum, another value of k. Will be k plus 1 over 2. We proceed to the next step. We need to prove that p n equals to k plus 1 is true. Okay. Try to look step 2. Okay, saya buka besar sikit. Okay. From the second step, it's the summation from 1 until k. This is the summation until k plus 1. 1 plus 2 plus 3, you will arrive at k first. After k will be k plus 1. You need to show it will be equal to k plus 1. This one will be k plus 1 over 2. It's very good if you can compare this with this and this one with this. Second step is k. the third step is k plus 1. Now we have left hand side and we have right hand side. So right hand side can be get very easily here. You just simplify the algebra here, becomes this. The challenge is we want to show the left hand side for the step 3 will be indeed the same representation as the right hand side. So by using assumption 2, itu yang saya cakap tadi, by using assumption 2, from assumption 2 we believe the summation until k will be k plus 1 over 2. Don't forget you need to add up k plus 1 here.
From alright, I proceed. This one will be equal to k plus 1 plus 2k plus 1 over 2. Compare left hand side and right hand side sekarang, tak sama lagi. You kena bagi sama. Kena bukti. Apa dia? Tak sama lagi.
Tapi boleh expand, boleh samakan denominator.
Yes. Musin ke tu? Okay, yang Musin, kita kena tunjuk dia betul-betul. Macam mana nak bagi sama. Macam Musin cakap, dia kena expand. Dia boleh factorize. Yes, you can do that. But some, because this is a common factor here, then you can directly put here k plus, I miss my whiteboard. K plus 1, k plus 2 over 2. Now, left hand side is equals to right hand side for pk plus 1. For the case of k plus 1 is also true. Okay? Make sure you tunjuk ini. Ada setengah student dia ngelat. Dia terus tak buat yang ni, yang biru ni dia terus tulis yang bawah terus. Mana boleh? Dia mesti ada jalan dia. Okay, like Musin said, sometimes the student expand. Sometimes the student expand also can. Kalau kita nak expand dulu, dia jadi jalan lagi panjang, boleh, tak ada masalah. Dia jadi k squared plus k plus 2k plus 2 over 2. It becomes k squared plus 3k plus 2 over 2. Then you k plus 1, k plus 2 over 2. Also can. Asalkan with a valid expansion and factorization, you will show that it is correct. Some of my students who are not very good in factorization, they indeed expand the right hand side. And then after they get k squared plus 3k plus 2 over 2, dia kata sama dengan yang ni. Pun boleh. As long you show that by a valid process, it will be similar. So at the end, step 1 is true, step 2 is true. Step 2 we assume to be true. By using assumption 2, you show that step 3 is true. Then you put the largest conclusion. What you just proved just now is not simply a step 1, step 2, step 3. You just proved by using mathematical induction. I managed to prove to you that 1 plus 2 plus 3 plus until a certain number of n will be this formula. Not only for a single one, for every possible positive integer out there. So after this, when I ask you what is the summation of 1 plus 2 until 2020, you tak payah ragui dah formula ni. This formula is correct and this formula will be 2020 times 2020 plus 1 over 2. And the Gauss is right. Okay, kita tengok betapa panjangnya solution tu. Tulisan saya pun besar lah kot. So, mathematical induction, the step is long. Especially for the step 3. Mathematical induction question always entitled for 10 marks. 8 to 10 marks. Give and take. Alright, ada soalan setakat ni? Ada soalan setakat ini? Ke dah putus lah internet saya? Respond please.
Ada soalan saya?
Okay.
Tak ada.
Okay. After this, you sama kan dengan video saya tunjuk tu kan? So, kepada yang kurang faham, okay, boleh tengok balik video saya tu berulang kali. Ada soalan nampaknya? Tak ada. Okay. So if no question, so I hope we can continue this. Next Tuesday, we will do a couple more of induction question for you to get ready for your assessment test 1. Okay, soalan kita dah habis lecture untuk hari ini. Tapi saya tanya subjek saya lagi satu tu. Saya tanya test selesa buat waktu malam ke atau waktu kelas. Sebab hari tu test untuk saya lagi satu subjek tu kawan saya Madam Intan tu dia buat waktu malam. And then surprisingly enough they said that malam lagi menyenangkan diorang. Itu student subjek tu lah. So saya saja sebelum kita tamat ni, saya tahu dah ada pukul 12, saya nak tanya sekejap je. Adakah malam possible untuk kamu semua?
Yes, possible.
Possible. Ada tak yang tak possible? Saya nak dengar yang tak possible sebab apa? Sebab yang group lagi satu tu, subjek lagi satu tu, dia cakap malam lagi senang sebab tak ada kelas. Siang dia duduk kelas, dia serabut. There are too many class during the day, so they are more prepared during the night. Betul ke? Ada tak yang tak setuju buat malam? Cuba nyatakan sekarang. Saya nak tahu yang tak setuju. Yang setuju okey lah. Okey lah guys. Oh okey, Hafiz setuju malam. Yap, setuju malam. Dia sebenarnya kalau malam menyenangkan kamu, dia terbalik kepada saya. Sebenarnya. Malam dia menyusahkan saya. Tapi tak tahulah, tengoklah macam mana. Saya akan buat keputusan nanti. Tapi maksudnya kalau setakat ni tak ada orang yang menentang, so saya ada option lah. Ada tak orang yang saya sekali lagi tanya yang tak setuju waktu malam?
Okay, nampaknya tak ada orang yang menentang buat masa sekarang. So right now, I assume that if I was given option to do the alternative, then I will announce it. So ramai setuju, so terpaksa setuju. Alia, okay. Alia tak setuju, kenapa Boleh je Alia. Last kali keputusan tu atas saya juga. Alia kenapa tak setuju? Alia? Mana boleh, janganlah, kita negara demokrasi. Tak setuju apa pasal? Boleh. Tak ada saya okey. Oh, okey. Alright, kalau tak ada apa, thank you so much. Malam lepas pukul 8 okey. Alright. Saya kalau ikut saya malam lepas pukul 12 baru saya okey. Okay, fine. It's good to know for me to have the alternative. We have a good session today for me also. Thank you so much for coming. And I hope to see you guys again for the next Tuesday. Sun Kenya pukul 11 tau, tak boleh tau. Lama sangat Sun, I tahu. Oh, you kerja ke? Tak apa, kita PM Kalau I try set masa dulu. Tapi pukul 11 malam will be too late soon. For the other students. Saja. Ni night owl ni orang. Okay, tak apa. Saya habiskan juga. Thank you so much. I will stop recording right now. I hope that you will self-learn more on the mathematical induction before we challenge ourselves with more